Hello, my name is Hideo Nagahashi, and today I want to talk about matrix multiplication. So let me start. So first of all, let me start from the bad example. What you should not do. So suppose you have two matrices. We have learned that you can add two matrices of the same size by simply entry-wise. Okay? So your natural guess to how to multiply is simply again an entry-wise. So in other words, it's very natural to do this way. So 1 times 5, 2 times 6, 3 times 7, and then 4 times 8, which is 5, 12, 21, and 32. Okay? Then this is wrong. Okay? So don't stop watching this video. Okay? At this point. So no, the reason is actually it's not easy to say in the one word. So you'll see that later. But at least there's nothing wrong with defining the multiplication this way. But it turns out this definition is not productive. Okay? So that's why people just don't take this as a definition. So since the real definition is a little complicated, so let me just explain the real definition step by step. So first of all, you can only define the matrix multiplication A times B, not necessarily the same size, but like this. Suppose A has size m by n, and then B has n by p. Okay? If you have the same number of columns for the first one, A, and I'm sorry. Let me just say again. If you compare the number of columns for A and then number of rows for the B, if they agree, then you can multiply. Okay? If not, you cannot. Okay? So let me start from the easy example. So for example, so 1, 2 times 5, 7, but this matrix is 1 by 2. Okay? The 1 row and 2 columns. This one is 2 by 1. So it's 2 rows and then just 1 column. So then you see that, so these numbers are the same. Okay? So that's why you can multiply these two. Then actually the result is, I forgot to tell the result is, this has size m by p. Okay? So the product is m by p. So which means for this example, your product has 1 by 1 matrix, which is just simply the number. Okay? It's 1 by 1. Then, so how do you compute? The definition is you just simply multiply the first column and first row here. Okay? So 1 times 5, then you multiply 2 and 7. Then you just add it here. Okay? So which is now 19, which is just a number here. Okay? Which is in 1 by 1 matrix, okay? But it's really a number. So that's like the simplest, okay? The example here. Okay. Now, let's look at the more complicated example here. Okay? So 1, 2, 3, 4 times 5, 6. So you always have to check the size first. So this is 2 by 2 matrix, and this is 2 by 1. Okay? Then you always have to check the matching here. Okay? So 2 and 2 are same. So you can multiply these two. Okay? Now the result is 2 by 1. Okay? 2 by 1. So that's why now it looks like this. Okay? The two numbers. So now how do you get these two? So to compute each entry, actually just the variance of it's just applying the first example. Okay? So it's good to know. So you just split like this. You don't. It's not necessary, but this helps you to compute. No? So what you can do is, well, look at this, the 1, 1 entry of the product. Then what you do is you just multiply the first row and first column like this. Okay? So 1, 2 times 5, 6 comes here. So it's 1 times 5 plus 2 times 6 here. Okay? Now, if you want to compute 2, 1 entry, okay, then what you do is you multiply the second row, row 2 and column 1. Okay? So row and column. So that's how that is the rule. So 3, 4 times 5, 6. So you have 3 times 5 plus 4 times 6. Okay? So once you set it up, so then you just need to compute each number. So 5 plus 12, so that's 17. 15 plus 39. Okay. Okay. Now let's tackle the original program. Here. Remember? So entry-wise multiplication is not what we want to do. So here is the definition. So first of all, so let's check the size. It's 2 by 2, 2 by 2, so everything is 2. So they're matching, so it's okay. And then the result is also 2 by 2. Okay? But it's not entry-wise. Okay? So what you do is, so first of all, so you have 2 by 2 matrix as the answer. So it looks like this. Then as before, so I suggest you just split the first one row by row. Then now you split the second one, now column by column like this. And that helps you to compute the product. So again, the rule is same as the second example. So what you do is 1, 1 entry. 1, 1 entry comes from the first row and the first column. So that comes from the 1, 2 times 5, 7. So that's 1, 5 and 2, 7. Okay? Now let's do the 1, 2 entry. 1, 2 entry of the product comes from the first row and second column. So it's 1, 2 times 6, 8. So it's 1, 6, 2, 8. So, then 2, 1 entry comes from 3, 4, 5, 7. So 3 times 5, 4 times 7. Then finally, the 2, 2 entry comes from the second row, second column. So 3, 4, 6, 8. So 3 times 6 plus 4 times 8. So I have 19 and 26 and 28. So it's 43, then 50. Okay. So this is obviously different from the entry-wise. Okay? Then, so later you will see why we have to define this way. But let me point out something interesting here. Okay? What happens if you switch the order? Okay. So until this point, so most of the algebra you have seen is you can always switch, it doesn't change the result. But in this case, you will see that now 5, 6, 7, 8 times 1, 2, 3, 4, you have 5, 1, 6, 3. Now 5, 2, 6, 4, 7, 1, 3, 7, 2, 4. So what you get is 23, 34, then 31, 32 plus 14, so 46. Okay. So now, interestingly, the result is they are not equal. Okay. So if you call two matrices A and B, so they are not commutative here. Okay. Okay. Thank you.